with features like advanced optical detection and AI-driven navigation, the Smart Cane is breaking barriers and opening up new horizons to those who use it.
Yeah.
So, Song, before we started this recording, I had said to you, it really reminds me of a GPS type of situation for a visually
Mhm.
impaired person using the Cane 2.0. And you said it's really a companion to enable the free movement.
Mhm.
And I need to learn from you what types of the components. You mentioned the IMU and you've mentioned sensors. So let's talk components of this companion to enable
Okay. Yeah.
movement for the user. So how did the team choose which specific TDK Invensa sensors would be included in the Smart Cane? And what is the significance of each in terms of functionality?
Okay. So in Smart Cane 2.0, they pick four TDK sensors in their device, right? And of course, each sensor will serve a specific purpose. For example, I think one of the big key features in this 2.0 is that be able to detect overhead obstacles, right? Usually the traditional cane can only detect ground level obstacles. But if there's a tree branch or if there's a sign that on the like shoulder or head level, that's truly a hazard, potential hazard to the vision impaired people, right? So for that, they need a radar type of a device that can detect that, right? But for radar itself, it's too power hungry and then it's much more expensive components. So in this case, the ultrasonic based time of flight sensor from TDK InvenSense solve that really a problem perfectly. So it has a very low power consumption and then can detect a range from a 30 centimeter all the way to 9 meter. They can do that detection range, obstacle detection range. And then this actually enable the cane. The user can really set the distance, how much like a long distance of a warning they would like to hear, right? Because yeah, if you walk slow, you don't really care too much about 5 meters or 10 meters away. So you can really wait until they become close, right? So all these are the features that our ultrasonic time of flight sensor enables. Yeah. And of course, when you talk about the navigation, right? So GPS is a one way that can help with the navigation. But in some scenario, like is this you're in the urban center, so there's a really weak or a GPS signal, or if you're in the indoor environment, then there's total loss of GPS signal. In that case, will become the key components to help with that navigation. Yeah, because IMU, it has a three-axis accelerometer that measure the linear acceleration on the three axis. And then it also has a three-axis gyroscope that measure
So,
angular
so
change.
let me interject if I
Yeah.
can for a second. So IMU is inertial measurement unit.
Yes.
For our audience. So can you explain the IMU to our audience and in that
Yeah.
way?
So as you said, Sharon, yeah, it means inertial measurement unit. And then it's usually, yeah, we call it a six-axis IMU because it include a three-axis accelerometer and then a three-axis gyroscope, right? The gyroscope measure the angular rate change. The accelerometer, of course, measure that linear acceleration, right? And then by combining these two devices together, so we can really give accurate measurement of like the speed or the direction of one person's travel, and also their orientation or their heading at any moment, right? And then also since InvenSense is a MEMS company, so we build those IMUs using MEMS technology, and of course MEMS stands for micro electrical mechanical systems. So these are basically we shrink the actual mechanical device to a wafer level, right? And then so that's enable really the very compact device that still performs a very big functions, right? And then in this case, so we achieved the accelerator by really have create some very tiny proof mass that connect to some springs that really measure those when you do the acceleration, right? We measure the capacitive change and then convert them into a voltage signal. Yeah. And
How
then
are all those sensors interacting with each other? How are they communicating with each other?
so we communicate, the IMU has like a serial interface, right? Either I3C, I2C, and also we support SPI. So the customer will pick a different interface, depends on what's already available in their system, or depends on the speed, how much data they want to transmit, right?
So now you mentioned the MEMS. So tell me about the microphone that's used to help the user interaction and the features that that microphone has.
Yeah. So the microphone is also based on the MEMS technology. And then we have our microphone, we offer both digital and analog based MEMS microphone. And then I think the one in the cane is the digital microphone. It's really support either SPI or I2S interface, right? And then so in order for the user to really can clearly communicate their voice command, I mean, in a like noisy environment, they need the microphone to be really highly sensitive and has high like SNR, and then also at the same time consumes low power. So these are really the highlights or the features of InvenSense microphone. Yeah. And then we also have a pressure sensor there that can help to measure the elevation of the person or device, right? If they're on the second floor, on different floor, right? They can sense that. And then the way they do the design. So the field of view is designed at a 45-degree angle. So when you hold it, it's really pointing the wave to the overhead level. That's around your like shoulder or head.
So do you want to talk a little bit more about those time of flight sensors?
Yeah, so the time flight sensors is basically they measure the time of the ultrasound bounce back from a object, right? And then use that, they can calculate the distance. And then, so that's how you do the obstacle detection. And then also it do it in real time, which means, yeah, it can really sense if you're closing to the obstacle. And then in this case, for the cane, they will send out those either audio response like the beep, and then the frequency of the beep really, yeah, show you how close you are. And of course,
Okay.
you can also change that feedback to like the move the vibration of the
Like a
cane.
haptic? Okay.
Yeah, haptic. Yeah.
Okay. I understand there's other components on the WeWalk cane that come from TDK. Do you want to tell us about those?
Yes, you're right. So on the cane smart cane, we also have TDK multi-layer chip antenna that really send receive signals to the required frequency. And then there's also metal inductors for the power circuit. And then last but not least is there's some multi-layer ferrite inductors for decoupling the circuit. Yeah.
Okay. Terrific. So we always have to be forward looking. So do you anticipate at all any upgrades to the Smart Cane going to a 3.0? And based on emerging technologies or user feedback, would TDK say could be next for the Smart Cane?
Yes, yes, I'm sure there will be a 3.0. And then, yeah, in fact, we already kind of talk about some features that they need. And also from our side, we also recently released a newer generation IMU that is run even further consume even less power. So which is definitely help with the overall power consumption as in the device, right? And then also in this IMU, we have more like a machine edge intelligence, which go back to your previous question. So customer can offload some of the computation or even the intelligence to the IMU sensor itself instead of have to rely on maybe the system processor to do that. And then maybe even, can even when you don't have a connection with the phone. So that's give the cane still a much more like local intelligence to perform some function. So yeah, that this kind of new generations of IMUs, that's the one definitely will be in the 3.0 that will help them to further expand the battery life and then bring more local intelligence.
Great. Well, I can't thank you enough, Song, for being here with us today. And thank you all for joining us. So until next time, I'm Sharon Spielman with Machine Design. Stay curious.